Hello everyone, welcome to the channel IGCSE and GCSE Maths School. I'm Saman. Now we are discussing a set of questions, set of examples related to upper bound and lower bound after finishing the theory parts of upper bound and lower bound and rounding off numbers. So there's a playlist created in the channel IGCSE and GCSE Maths School by the name rounding off numbers and upper bound and lower bound. In that playlist, all these videos related to upper bound and lower bound, rounding off numbers, and all those are included, all theory. And these examples are also in that playlist. Therefore, go to the playlist and watch those videos. And okay, now today's video. Can you solve this question? Can you solve this problem? See. Can you solve this maths problem? Okay. If A equals B plus C over D plus M, where B equals 26 to 2 significant figures, C equals 3 to nearest unit, D equals 8 to nearest unit, and M equals 5 to nearest unit. Find first part, upper bound and lower bound of A, second part, range of values of X. That is the question in the same vein as most of the other questions that we have discussed up to now, right? Okay, now let's see how to solve this question. If you have an idea to solve this question, then you solve it alone and compare with my answer. Okay, I'll start solving. Pause this video and solve on your own and compare your answer with mine. If you have if there are any mistakes in your answer, then correct them and try to understand. And then I am solving. Okay, now this question, A equals, there is an equation, A equals B plus C, D plus A over D plus C. Right now, you must be able to make out that this is a division. You must see this as a division. You must be able to make it out as a division of two terms. This is one term, this is another term. This is a combined term, this is also a combined term. Okay, right, now look at here. Then this is called, now in the division case, in the case of division, this number, the top part, number statement above the line is called dividend. This is called what? Dividend. Then this statement below at the bottom is called device. Okay, device. Right now, then dividend is divided by divisor, you get an answer that is called quotient. What is that? That's called quotient. Here then, A is the answer after dividing this block of B plus C by this block of D plus M. Therefore, A is the quotient of this division. A is the answer of this division, and therefore A is the quotient of this division, right? Then we know now we are asked to find the upper bound and lower bound of A. Then upper bound and lower, to find the upper bound and lower bound of a quotient, we have learned a particular formula for finding the upper bound and lower bound of quotient. So you may remember we have learned before, the upper bound of quotient equals upper bound of the dividend divided by lower bound of the dividend. Upper bound of quotient equals upper bound of the dividend, that is the upper bound of the part above the line, divided by the lower bound of the part below the line, otherwise called what is called divisor. Okay, therefore we will write the formula for the upper bound of this one. They like upper bound of A equals, what is that? Upper bound of the dividend. Upper bound of dividend. What is dividend here? B plus C. And divided by lower bound of the divisor, that is lower bound of this bottom block of the term, then that is lower bound of D plus M. Okay, that's simple. Now Then we have learned another formula for finding the lower bound of a quotient. How do you find the lower bound of a quotient? Simple formula. The lower bound of a quotient equals lower bound of the dividend divided by lower bound of the divisor. I'm sorry, I have a mistake. Lower bound of the formula for finding the lower bound of a quotient is the lower bound of the dividend divided by the upper bound of the divisor. Then lower bound of a quotient equals lower bound of the dividend divided by upper bound of the divisor. Therefore, the lower bound of A, that is the quotient, must be equal to the lower bound of B plus C divided by upper bound of D plus C. Then you write that formula also, right? Then here, a lower bound of A equals then what? A lower bound of this lower bound of B plus C divided by upper bound of the divisor, that is D plus M. Okay, these are the two formulas. Now we can find the answer. Now we need upper bound of D plus C and lower bound of B plus C, and lower bound of D plus M and upper bound of D plus M. These things we need. We have to find those things now. I will find them as workings, right? Now write B plus C. We'll first write B plus C, then upper bound of B plus C equals, now this is what? This is sum. B plus C means B addition C. B plus C is a sum of B and C. Then upper bound of B plus C means upper bound of a sum. We have learned how to find the upper bound of a sum. That is what? Upper bound of a sum equals sum of the upper bounds. Upper bound of a sum equals sum of the upper bounds that of the numbers that have been added, right? Then upper bound of B plus C is therefore sum of the upper bound of B and upper bound of C. Therefore, write upper bound of B plus upper bound of what is that? Upper bound of what? Upper bound of C. Okay, that is the formula. Then upper bound of B. What is the upper bound of B? That is the upper bound of a single corrected value. The general formula applied for that is the corrected value plus degree of accuracy over 2. Then here, corrected value plus degree of accuracy over 2 here. Here also, upper bound of C also, corrected value plus degree of accuracy over 2. Right, now we'll find the corrected value of B. How much? Corrected value of B is 26 plus degree of accuracy, that is corrected 2 significant figures. 2 significant figures means the significant figures are counted from the left side of the number, left end of the number. Then left end of the number is this, that is that is a non-zero digit. Therefore, this is the first decimal place. Second, it's the first significant figure. This is the second significant figure. Second significant figure is 6. That is in the unit place of the number. Unit place. Unit place means that this number has actually been corrected to nearest unit. 2 significant figures means in this instance is 2 nearest unit. Nearest unit means 1. Corrected value to be used in the upper bound formula is 1 over 2. Right? Then second one. Then correct the upper bound of C. Upper bound of C is also upper bound of a single corrected value. The general formula for that is corrected value plus degree of accuracy over 2. What is the corrected value of C? That is 3. This is 3 here. This is 3 plus degree of accuracy of C value, but nearest unit. Nearest unit means what? If the number has been corrected to nearest unit, degree of accuracy to be used in the upper bound, lower bound formula is 1 over 2. We have discussed in our previous videos those points, right? Okay, go to the theory in the playlist and watch those videos, right? Okay. Now, next one now. Here, this one, how much? 26 and half, that means 26.5. This is 3.5. Then all together, how much? 30. This 30. Okay, that is the upper bound of B plus C is 30. Then lower bound. Lower bound of what? B plus C. Lower bound of B plus C is what? Lower bound of B plus C, lower bound of sum here. Here also B plus means it's a sum. B addition C, that means it is a sum. Two numbers have been added. Then this is the lower bound of sum of B plus C is equal. Then there is a formula for finding the lower bound of a sum. That is, lower bound of sum equals sum of the lower bounds of the two numbers, right? Then lower bound of B plus C equals lower bound of B plus lower bound of C. Then you write here lower bound of B plus lower bound of what? C. Okay. Now what is the formula for finding lower bound of a number? Lower bound of B means lower bound of single corrected value. That general formula can be applied. That is corrected value minus degree of accuracy over 2. Then to find the lower bound of C also, that is C also, we can apply the general formula, that is corrected value minus degree of accuracy over 2. Lower bound of B, corrected value minus degree of accuracy over 2. What is the corrected value of B? Corrected value of B is how much? 26. 26. What is the degree of accuracy? Then the second significant figure. The two significant figures here, the second significant figure, that's place value is unit, so therefore it's 1. 1 is the corrected degree of accuracy. Then LB, lower bound of C. What is also the corrected value minus degree of accuracy over 2. What is the corrected value? C, 3. 3. Then plus 1. 3 plus 1. 3 plus degree of accuracy over, sorry, not 3 plus, 3 minus, right? Sorry. 3 minus, because lower bound means corrected value minus degree of accuracy over 2. 3 minus degree of accuracy over degree of accuracy of 3 means unit, 1 over 2, right, like this. Okay. Then 26 minus half means 25.5 plus 2 and half. Okay. 2 and half. 2 and half and 25.5 means how much? 28. That is 28. Okay. Now lower bound of B plus C is 28. Now you need to find the lower bound, upper bound of D plus M. Then find lower bound D plus M. Then you write D plus M. These are the values of D plus M, right? Then you find upper bound of D plus M equals, what is that? Again, the same thing, upper bound of sum is sum of the upper bounds. Then write upper bound of what? D plus upper bound of what? M. Upper bound of M. Okay. Upper bound of M. Then upper bound of D is upper bound of single corrected value. The general formula can be applied. That is corrected value plus degree of accuracy over 2. Corrected value plus degree of accuracy over 2. Then upper bound of M is also upper bound of a single corrected value. Same formula applies. Corrected value plus degree of accuracy over 2. Right. Okay. Now you can find use by substitution. Now say a corrected value of but D. Corrected value of D is 8. That is good. Then plus degree of accuracy, the two nearest units. See, nearest unit, that is 1 over 2. Degree of accuracy is 1 over 2. Then plus corrected value of C. Corrected value of C is how much? Sorry. Corrected value of M. I'm sorry. Corrected value of M is how much? 5. It's 5. Then 5 plus, what is the correct degree of accuracy? 5 correct to nearest unit. Look at nearest unit. Nearest unit means degree of accuracy is 1. Okay, right. Now here you can write 8 and means 8.5 plus 5.5. Then that answer will be how much? 40. That is 40. That is the upper bound of D plus M. Then you will find the lower bound. Lower bound of what? D plus M. What is how do we find the lower bound of D plus M? Lower bound of D plus M is like the lower bound of sum. Lower bound of sum equals sum of the lower bounds of the numbers added. Therefore, we can write this lower bound of D plus M equals lower bound of D plus lower bound of M. You can write this. Lower bound of D plus lower bound of M. Okay, right. Now we found. Then lower bound of D. Lower bound of D. Lower bound of D is lower bound of a single corrected value. Then to find lower bound a single corrected value, general formula is used, that is corrected value minus degree of accuracy over 2. What is the corrected value of D? That is corrected value of D is how much here? 8. You can put 8 here. 8, then plus degree of accuracy is nearest unit. 8 is 1 over 2. Okay, that is plus minus, sorry, over. Okay, this one. Then plus corrected value minus degree of accuracy over 2. That is the lower bound of a single corrected value. Right, then this one, lower bound of M. What is the lower bound of M again? The corrected value of M plus, sorry, corrected value of M, minus degree of accuracy over 2, right? What is the corrected value of M? That is 5. Then minus the nearest unit, that is the degree of accuracy that has been corrected to nearest unit, the degree of accuracy is 1 to be used in the lower bound, upper bound formula, right? Then this is the right calculation. Then 8 minus half means how much? 7.5. Then plus 5 minus half means how much? 4.5. Then after adding those two, how much are you getting? 22, right? 7.5 plus 4.5, 12, no? 7, 4, 11, 12. So yes, 12. Okay, 12. Okay, now right. Now we have found the necessary information to be substituted to define the these formulae to find the upper bound and lower bound of A. This is the answer for the first part. Okay, now write upper bound of, we can substitute upper bound of B plus C. Upper bound of B plus C is 30. Then divided by lower bound of D plus M. Lower bound of D plus M is 12. All right. This can be very clearly cancelled. You can divide this by 6. 6 times 1. So 6 times 2. 6 times 2, 6 times 5. 2 divided by 5 means 2.5. Okay. That is the upper bound of it. Now go to the lower bound of A equals lower bound of B plus C divided by upper bound of D plus M. What is the lower bound of B plus C? Lower bound of B plus C is this here, that is 28. Then that is divided by what? The upper bound of D plus M. Upper bound of D plus M is how much? 40. 40. Then 1, 2. This answer is 2. Okay. Now first part is answered. Now second part. Second part is the range. That is range is how defined? Always the range of actual value of the particular number or the corrected value is always greater than or equals the lower bound but less than the upper bound. Therefore we can write what is that 2 point this one. What is the lower bound of A? 2. 2 less than or equals what? Actual value of A, then less than upper bound of A, that is 2.5. Okay, that is the second part. Answer. The full question has been fully answered. I think you have had very good knowledge of this. I think just read this and watch this video again and again and try to enrich your knowledge of this area of mathematics. So therefore, now with ending the video, I want to tell you now, stay with us. We are posting videos continuously or almost daily. So they watch those videos and try to improve your mathematics to pass all recognized examinations like Cambridge O-Level, Edexcel IGCSE, GCSE, SAT, CAT, PSAT, NMSQT, and all such other parallel examinations. Okay, thank you for watching until the end. Have a nice time. See you. Bye. Expecting to meet you in another video very soon.